All right, 3.1, measures of central tendency. So we're going to look at 4 objectives here, so let's get started on this. All right, so first of all, a measure of central tendency numerically describes the average or typical data value. And the 3 most widely used measures of central tendency are the mean, the median, and the mode. Now, average usually refers to the mean. So when most people ask about the average, they're talking about the mean. But sometimes it can refer to the median or mode, so be careful when people are talking about the average. All right, so first let's look at the arithmetic mean from raw data. Okay, so the arithmetic mean of a variable is computed by adding the values of the data and dividing by the number of observations. Now, the population mean is denoted by this Greek symbol over here. And so you want to pay attention to it. It's pronounced mu, and it's computed here when we're talking about the population. All right, so we have a parameter on those. Okay, and you're going to see that throughout the rest of this course. So when you see mu at this point, you have to recognize that that is population mean. The sample mean is denoted by x bar. So you'll see it right down here. Now, anytime you see that, again, throughout the rest of the semester, we're going to be talking about the sample mean. So it's very important that you pay attention to those details when you're looking at those. Okay? All right. And so we typically just call this the mean instead of the arithmetic mean. Now, the official definition formula for the mean is denoted here with that, and it just means add everything up, divide by the number of observations on those. Okay? All right, so here we want to look at those things. We can find the population mean, and then we can also break it down into a sample of 4 students, and then look at those pieces, okay, with them. All right, so let's start with the population of all 10. So if we add all 10 of those things together, we get 790, and then we divide by 10 to get 79. So the mean of all of the scores for our population here is 79. All right? Now, if we want to do a sample of 4, here they're doing a computer-generated sample. In your homework, they'll give you the numbers or the people to do the mean on, so you won't have to worry about doing that part. We're going to be able to jump straight to the problem and do our sample. So here we just add up the ones that we want, and this time it's only out of 4. So because we're doing a sample, it doesn't come out to that same 79. We got 73.8 because of the people we chose in this sample. We do another sample, it's going to be a different number on those. They should all be relatively close to 79, but they don't have to be 79 specifically. Okay? Now, in the grand scheme, what does that mean when we're looking at a histogram on those? Okay, so we can see here the mean is going to be in the middle with those. All right, kind of the center of gravity when we think of those things, wherever our histogram is. Our mean is always going to be in the middle. All right. Median. Now the median is what lies in the middle. We use capital M to represent the median for those. Okay. So first, in order to find the median, we have to get it in ascending order, so numerical order with all of our observations. We determine the number, and then we find the one in the middle. Now, based on where that is, we can do some pieces, what number that is on those, okay? And so here's a couple of ways of doing that, but I want to show you some other ways without having to memorize a formula for those, okay? All right, so here we have another data set. We're looking at songs and their length, and so the first thing we do is we put it in order, okay? Now, when I'm doing these, I don't worry about doing that formula. What I do is I do just kind of some strike throughs to help me be able to do those pieces a little faster and not have to worry about memorizing that, okay? All right, so what I would do is, okay, we're going to eliminate one of them on each end. Then we're going to eliminate again, and eliminate again. Well, there is one left, so that there is our median. Okay, so 217 would be our median in this problem, and that's how we would do that. Okay. Sorry. All right, so they're going through the full calculations with that, and so they come up with the same number. Okay, now what about this one? So again, we arranged it in ascending order. I'm going to do my strike throughs again. So we have those two are gone, those two, and those two are gone. And we have 2 right here. So to find the median, we actually average those 2 together. We take 77 and 82, we add them together and divide by 2. And that's going to be what our median is. And so they're going to show that in the next few steps. Okay. All right, so this time there's 10 observations. They do all of those pieces. And so here we can see, just like I said, we add the 77 and 82, divide by 2. And so our median is 79.5. Okay. So it's all based on, do we end up with one thing in the middle or do we end up with 2 things in the middle on those? If we have 2, we need to find the average of those things, the mean of those. Okay. All right, now there are ways of doing it in the calculator. I'll show all those in just a moment when we get to the end here for our pieces, okay? Actually, let's go ahead and do that. My apologies. Let's go ahead and do those things, okay? All right, so let's turn on our calculator. I want to be able to find both the mean and the median here using this, okay? And so we want to do that. All right, so in order to do that, first of all, we have to put the data in. Our favorite button this semester is going to be the Stat button right over here, okay? So I'm going to hit Stat, and first I need to edit. So I'm going to hit number 1, or you can just hit Enter with it, and it's going to have those, okay? Now I need to clear that list, because I don't know how much is in there. So I'm going to go up to L1, I'm going to press Clear, and Enter, okay? Now to clear a list, you go up to the very top, where the L1 or whichever list you want to clear is highlighted, hit clear and then enter and it will clear that list. Do not hit delete. If you hit delete, it gets rid of the row and then you'll have to go back and reset your stuff to get your L1 and L2 back in there, and we don't want that confusion, okay? All right, so now we need to put those numbers in. So 82, 77, 90, 71, 62, 68, 74, 84, 94, and 88. So that one's in the 10th one, so we at least know we have all the right numbers there on those. Our last numbers in the 10th one, they had 10 students. I'll check and make sure all of them are at least double digits with those. You do need to make sure you be patient with your putting in your numbers, because if you type in anything wrong, it's going to miscalculate, okay? All right, so now we want to go back to Stat. So we're going to click on Stat again, and this time we're going to arrow over to Calc. Okay, so arrow to Calc, and we're going to do number 1. That is the 1 VARS Stats. So number 1, we want to select it, and then press Enter. So now we can see everything that it has going on. We have our X bar, which is our mean, is 79. We saw that earlier. Now these other things we'll worry about later, but for now we're going to arrow down. When you arrow down, you see some other numbers coming up. And again, these are going to be important numbers later on. But for today, we're going to focus on this one. Our median is 79.5, which is exactly what we saw a while ago. So you can get those things. It does everything for you in the calculator. So that's going to be helpful, especially as you get those bigger numbers. It's hard to put them all in the right order. All those things, you can type them in any order in your L1, and then you go into your 1 vars, and it will give you both the median here at the bottom, and at the very top, it will give you your mean for those. Okay? So that's how you can use that calculator to your advantage. All right, so explain what it means to be a statistic or a statistics resistant. Now, as we begin to look at these things and we start looking at the mean and median, based on whatever we're doing, those things can change pretty easily. All right, now they go through all these things and they notice a few items on them, okay? And so they're looking at those pieces. So here we can kind of see a dot plot of our graph. And we have this one outlier way over here to the edge at 48. And so that's really going to throw things off when we start doing some of our data, okay? And so if we were to do the mean and actually calculate those pieces, we would think that our mean is supposed to be way over here. However, that outlier is going to shift it way over on our pieces, okay? And so we need to be careful with that, all right? And so we can see here that the mean was at 7.25. But when we look here, 7.25 is over here in the middle, or after the 7, and that doesn't represent the middle of my data. So that means that it's not resistant. But however, our median was 3 point something, which does make sense. It's toward the middle of our data here with those, okay? All right, and so the median would be better when we're talking about this set of data compared to the mean. Now, resistant means that extreme values, like that 48, do not affect the data values, okay? So we got to be careful with them, all right? All right, so within some of these pieces, those being resistant or not, mean is typically non-resistant. You do something, throw a large value in there, an outlier, it will really affect the mean. And so that's what's showing here in these. Now, if it's symmetric, the mean is good. But if it's skewed left or right, our mean isn't where the bulk of our information is. It's over in the tail, okay? Whereas the median will typically be will always be in the middle of our data, okay? So half of our information is bigger than the median, half of our information is smaller than the median with those, okay? All right, so here we can go through all those things. We can put that into our calculator. I'm not going to do all that. That's a lot of information, but we want to look at, which one describes everything best here. So again, they show going in and finding those pieces when we're looking at them. All right. All right, so when we're doing that, we find that both the mean and the median are kind of in the middle. This one is what we would call somewhat bell-shaped with those. So either one of these would be good for describing this data. Okay. And so typically the mean overrides when that's the case. All right, the mode. Mode is the most frequent observation that occurs in a data set. We can have no mode, we can have one, or we can have more than one. Okay. If no observation occurs more than once, we say no mode. All right. All right, so here we look at these O-ring failures on this spaceship. And so we can see we've got a whole bunch of zeros, some ones, a 2, and a 3 on them, okay? And so when we look at that, there's a bunch more O's, zeros, than there are 1s, 2s, and 3s. And so therefore, the 0 is the most frequent, and it is the mode. All right? All right, so here we look at them. There's none of these that appear more than once, so there is no mode. Okay? Now, if a data set has two modes, we say it's bimodal. If it's three or more, we call it multimodal. Okay, and the mode is not usually reported for this type of data. All right, and so this is what they would look like if we had bimodal or one mode with those. Okay. All right, so here we have some injuries. The mode is in the back at 12. All right, so we're just breaking down those pieces and look at it. Here's kind of a summary of all of those things, kind of giving you when to use and all of those pieces, so you can always look back at those and see what's happening there. All right. All right, so that's all that you should need to know for 3.1.